All right, so in 213, we're gonna do exponential and log equations and inequalities. So we bring back the solving of the log equations from Algebra 2 honors, and we introduce the inequalities. There's gonna be a couple different ways to do these, some using your calculator and then some just by hand algebraically. It starts with the review of like the inverse though, because we're gonna kind of pull this in with the graphing calculator. So example 1 says the function g is given by g of x equals the f negative 1 of x. And then it says find the value where g of x equals negative 2x. And it gives you f of x is 8 times 3 to the x minus 1. So if g of x is f negative 1 of x, what does that mean you have to do? I have to find the inverse of f of x first. So the first thing I'm going to do, this becomes y. I'm going to switch it. And then I have to isolate that y. So what's the first thing you're going to do? Divide by 8. X over 8 equals 3 to the y minus 1. And then how am I going to get to that exponent? Good. I'm going to log base 3. And then on the left it stays. On the right-hand side, log base 3 of 3 to the y minus 1 becomes just y minus 1. Good. And then the last step to get the y by itself would be add the 1. So y equals log base 3 x over 8 plus 1. And if I was writing this as an answer, what do I have to do with that y? I'm going to have to make this f negative 1 of x. In this case, it's also g of x. So you could use either one because either one is the inverse of this. Questions so far? So that's the first part is inverse, and some of the questions on the homework will just ask for that. But then the second part says find where g of x equals negative 2x. So algebraically, I'd have to set this equal to log base 3 of x over 8 plus 1 would have to equal negative 2x. And this is where it gets really sticky. Like you'd have to have 3, pick up the negative 2x. So I would say there are easier, more basic equations in which you would have to set it equal to something. Usually it's numeric and then solve it. And then there's ones like this where instead of doing it algebraically, I'm going to actually utilize my graphing calculator. So if I want to find out where those two functions are equal, what do I do?
Y equals.
Put them each as a y equals and see where they intersect. Good. So we got to figure out, obviously, now we have to do our log base change in our y equals, okay? So I'm going to do this as 1. That'll be my y1, and this as my y2.
Is this in the y equals?
Yep. So I'm going to y equals. I'm going to clear these out. And I'm going to go type in, and it doesn't matter which one you do, which one, but I just said I was going to do that log 1 first. So in order to get log base 3, remember, go to math. Go to math and go to 0, or go to A, actually, sorry. That's log base, and it's going to give you log with the little base. I'm going to change it to 3. Inside the parentheses is what's next to the log. So this is going to be x over 8. You could have made that a fraction, or you could have made it literally x/8 like I did. The plus 1 goes after the parentheses because that would be that vertical shift. Then I'm going to go to the second one and I'm going to type negative 2x. And then I'm going to hit graph. Oh, I got a plot in there. So my window is all weird. Let me change it. Would have normally been... Yeah, I'm going to mess with it anyways, though. So this is what it looks like as is. Okay, now on this example, it's clearly in there. The intersection's in there. It's not always going to happen. If the intersection is happening to the right, you're going to have to adjust it. You can zoom out, okay, or you can adjust it by adding on to your x. If it was high up, obviously you can add on to your y. I only need that intersection. I don't need anything else there.
There isn't anything we can press.
It's not like a stat plot. Yeah, no. So I'm going to go alpha, trace. Nope, I'm going to go second, trace, and I'm going to go to intersect, which is 5. And it's going to ask me which curve is my first. It doesn't matter as long as your little spider is somewhere on that curve. So as long as that's there. And then it's going to jump to the second curve. Now I highlighted the red one as my first one. And if you look at, well, let me just highlight what's happening. So if you look at what's happening, the x is 0 and the y is not there. Why is that like that? There's no part of my domain that's back there, right? If I kept going left, my x is getting less and less and less, but there's no points on that blue curve because the log can't be less than 0. Does that make sense? So that's going to come in tomorrow too when we talk about it. All right, then I'd go to blue and I'd hit enter. And there's my intersection. Yeah. A little bit weird because it says find the value where f or g of x equals negative 2 of x. And what it's actually looking for is the y value here. It's not asking at what value does it intersect, but specifically the value where it intersects. So there's a question on the AP Classroom homework. You'll see, I think it's like the very first one, and where it gives you multiple choice, so you can kind of figure it out from there because it was only one of them works. But if it was an open-ended question like this, it's actually looking for the y value where it intersects. So negative 1.291 would be the value in which these intersect, okay? So you just got to look for that intersection. There are going to be some we do by hand, and then there's some that are graphing, and obviously that's how we do the graph. Questions? All right, so now we're going to review a little bit of log stuff. So there are going to be log equations that you can solve without your calculator, and then there are going to be log equations that you have to use your calculator. When we get to them, you'll kind of see the difference. So the strategies when you have a log in your initial equation, and it could be a log or an ln, because an ln is a log, go like this. If there's one log on either side of the equal sign, then we use the one-to-one property to solve it. So if it said log, got a color you can read, like log of x, they won't be this simple, but let's just say it said log of x and then log of 2x plus 3, something like that, then we can actually disregard the log part and we set what's next to it equal. And that is because they could eventually convert into exponential, and we can do the same thing with the exponential. So if the base on the log is the same, if they were both 10s or 3s or whatever it is, then I literally ignore the logs and I set what's next to it equal to each other. That's one method. If there's multiple logs on one side or both sides of the equal sign, then the first thing we're going to do is condense it so that they're down to just one. So if I had log of x plus log of 2x plus 3 equals something, and that something will change, on the left-hand side, I'm going to condense that so that it becomes just one log. And then I would multiply that out. Make sense? Okay. If on the other side of the equal sign is another log, then I would do the one-to-one property. I would ignore the logs and I would set them equal to each other. If on the other side of the equal sign instead is a number, like 3, let's say, now I'm going to convert it to exponential, because if there's only one log in my equation, this would be log base 10. The 10 would come over, pick up the 3, and I would solve it that way. So each time you get a log equation, your strategy is going to change depending on how many logs are there, basically. Multiple on one side, we condense. Log on both sides, 1-to-1. Log on one side, convert to exponential. And then really important there at the bottom, I kind of drew through, but really important is that log expressions are defined only for logs of positive real numbers. So if I had this, let's just say I had this question at the top, and I got rid of my logs, and I got x equals 2x plus 3, and then I subtracted the 2x, and I got negative x equals 3, and my answer was x equals negative 3. You have to check these answers, and you're not checking them to say, are they bigger than 0? Because they don't have to be bigger than 0. What they can't be is when I plug it back in, what's next to the log cannot be 0 or less than 0. So it can't be 0 because we can't find log of 0, and it can't be negative because we can't find the log of a negative number. So if I were to take that negative 3 and I plug it back in to either side, if it doesn't work on either side, then I ignore that answer and it would be no solution. If it works on one side, not the other, not okay. It has to work for both. But again, the rule is not that it can't be negative. It's that if it's negative when I plug it back in, what's next to the log is not bigger than 0, then we can't keep it. Valeska.
You said x equals 3 is not a solution.
It was -3. 3 would have been fine. -3 is what it can't be. It couldn't be 0 or, right. It has to be bigger than 0. It can't even be 0. So, but like, let's say what's next to it said log of x -2. Well, now a -3 work. No, sorry. X, do it the other way around. 2 minus x. Now -3 works because if I plug -3 in there, I get 2 minus a -3, which becomes 5. So it's after you simplify what's next to the log, that's what you're checking to make sure it's above 0.
So are these the ones where you plug in?
Correct.
Solution?
Yep. Yep. And again, anytime there's a log in the equation, so a log or an ln. All right, so this one just says solve the equation. So what are we going to do first for A? Condense. I want to get that down to 1 log. So log base 3 of x times x minus 2 equals log base 3 of x plus 4. Now I have 1 log on either side of the equal sign and it's the same base, so I literally get to ignore that log. And I would distribute, so x times x minus 2 becomes x squared minus 2x equals x plus 4. Then what? What do I have to do when there's an x squared and an x? Get it all to one side because I'm going to have to factor this. So subtract the x and the 4, and I get x squared minus 3x minus 4 equals 0. So I'm looking for the factors of -4 that sum to -3, -4, +1. And then I split and solve this, and I get x equals 4 and x equals -1. Am I done? No, we have to check. So I'm going to check 4. If I plug it in, it's fine here. If I plug it in there, it's fine. If I plug it in there, it's fine. When I check -1, if I plug it in here, let's say, it's fine. But if I plug it in here, I end up with a negative next to my log. Same would happen here too. So I ignore the -1 as the answer, but I get to keep the 4. Questions?
And you have to plug it into all the...
You have to check all of them. If it doesn't work on 1, you're done. You eliminate it. But if it works on 2 and not the 3rd,
And if it
you have to
doesn't work, what would we say? No solution?
correct. If it was the only answer and it doesn't work, no solution.
Okay.
All right, go to B. So we're going to condense on the left side. Log base 5 of x times x plus 6 equals log base 5 of 16. Again, 1 to 1, so I ignore the logs. I get x squared plus 6x equals 16. Move the 16. Factor it out. Factors of -16 that sum to +6 are? Good. +8, -2, split and solve. And then we check. Does -8 work?
No.
Nope. Does 2 work?
Yes.
Yes. It doesn't mean 1 always cancels. There could be times in which you get 2 answers, okay? It doesn't, that doesn't always cancel out. So if it does, if you can keep 2, you can keep 2. Valeska.
Could you get no answer? There's no solution.
Could you? Sure. Either maybe 1 answer and it doesn't work or both answers don't work. Yep. Question. Okay. Now I've got a log on one side, but it's with a constant. And then I've got a log on the other side. So I can't do anything with that constant if it's with the log. I can't use the 1 to 1 here because there's a constant there. What I can do, though, is move both logs to the same side. So I can move this log over here, I mean, you could do either direction, but I would have kept it positive. And I would say 2 equals log base 3 of 4 plus log base 3 of x plus 5. Now I can condense the right side. 2 equals log base 3 of 4 times x plus 5. And now I only have one log. So instead of using the one-to-one property, I can't just ignore that log. I will use the exponential. So I would do 3 to the second equals, this drops off, 4 times x plus 5, and I get 9 equals 4x, God bless you, plus 20, and then solve for x. So subtract the 20, negative 11 equals 4x, and divide by 4.
If you know that 2 is log 3 of 9, you just do that.
What do you mean?
Like, you know.
Oh, like rewrite it?
Yeah.
Sure. Then condense. Yeah. They might not always work though. If that was like a 5, obviously you can't do it. But yes. All right, so we're going to check this, right? This time if I plug this back in, negative 11 over 4 plus 5, does that stay positive or negative? It's positive, right? Because this would be 20 over 4. I don't even need the exact answer. I just need to know that it's positive. So I keep that answer. Even though it's negative, when I plug it back in, it becomes positive, so I keep it. Somebody had their hand up.
Wait, how do you check this one?
You plug it back in. The only one that has the x is that log base 3 of x plus 5. So I have to do negative 11 over 4 plus 5 and make sure that's positive.
Because negative 11 over 4.
That's the answer.
Yeah.
Okay. All right, so now exponential equations. So now we're starting without a log, we're starting with an exponential equation. If it's exponential, there's 2 ways to do it. One is change the base to be the same and then use the one-to-one property. So we've seen things like that without a calculator, like a 2 to the x, let's say plus 3, equals 8. And I can rewrite 8 with a base of 2. I can rewrite that as 2 to the x plus 3 equals 2 to the third. It's a bad example because it's going to be 0, but either way. And then the bases are the same, so we ignore the base and we set the exponents equal to each other. That's one method, if I can literally change the base to be the same. The other is taking the log of both sides of the equation. So if I cannot make the base the same, if it said 2 to the x plus 3 equals 5, then in order to get that exponent out, I need to log both sides of this equation. Now I can choose what log to make it. I can make it log base 2 on both sides. You could ln both sides because at that point you will have a calculator, so it doesn't matter. You literally could take the log of whatever you want, and as long as you do the same log on both sides. So hang on 2 seconds. If I did let's say I did log base 2. The log base 2 cancels here. I get x plus 3 equals log base 2 of 5, and then I would subtract the 3 from it. So sometimes you'll see it literally written like that in your multiple choice. If you didn't have a calculator, that's how it would be left. And that log can change depending on what you're doing. If it was ln of 2, let's say, now my left side would look very different. The only way you're going to cancel out your base is if you keep the base on the log the same as the base of the one that has the exponent. With a calculator, I would continue to solve this to actually find what x is. Valeska.
Does taking the log of both sides still work for like the previous one?
Sure. Like I could do it up here. So I would do log of 2 to the x plus 3 equals log of 2, log base 2 of 8, right? This goes away, x plus 3 equals, and log base 2 of 8 is 3. So it works the same. Yep.
So if we didn't have a calculator, we would just solve for.
Usually you'll have one on something on the bottom. Like if the bases can't be changed the same, then you'll usually have a calculator.
Okay.
I would say an exception would be like if it's kept in terms of the log.
Okay.
Yeah. All right, so let's go with A. First thing I want to do is isolate that exponent, or the base with the exponent, right? So what do? Divide both sides by 4. And I get 1/8 to the x over 2 equals, what's 64 divided by 4? 16. Can I change these to have the same base? What's the common base? 2. Think about it, right? 8 is not a power of 4. It's a product of 4. Yes? It's a factor of 4. Does that make sense? If you don't see it, literally take that number and break it down in a factor tree. So this is 2 and 8, 2 and 4, 2 and 2. So this is 2 to the 4th. And this is 2 and 4 and 2 and 2. So that'd be 1 over 2 to the 3rd. And if I wanted to move it to the top, what do? Make it negative. So this becomes 2 to the negative 3rd raised to the x over 2 equals 2 to the 4th. As soon as I get those bases to be the same, I can ignore the base, and then I can keep the exponents. So negative 3 gets multiplied by x over 2 because you're raising a power to a power. So that would be negative 3x over 2 equals 4. And then I would multiply by 2 on both sides. Negative 3x equals 8. Divide by negative 3. And x equals negative 8/3. Now notice we didn't say anything about checking with exponentials, because can an exponent be raised to, can a base be raised to the 0 power? Yes, it's 1, right? Can it be raised to a negative power? Yes. So there's nothing an base can't be raised to. That's not like a log. And again, notice we did that without a calculator.
And because it's power to power, it turns into multiplied out of
Correct. Try B. All right, step 1. What? What do you do first? Divide both sides by 5. Then I get 3 to the x plus 4 equals 9. And 9 can be rewritten as 3 to the 2nd power. The bases are the same. We ignore those. Keep the exponents. And I get x equals negative 2. These can be checked pretty easily sometimes. Like if I just plug back in that negative 2, I get 3 to the 2nd. That's 9. 9 times 5 is 45. So those a lot of times don't take too much time to go back and check if you're unsure. Questions? Okay. Now it says solve and then check your answer by graphing. So we're going to kind of blend together what we did just now and then what we did with that very first example. So this time I have 1 log on one side. I want to isolate that log. So I'm going to subtract the 6. Log base 3 of x minus 2 equals negative 2. And then only 1 log, so I convert to exponential. The 3 picks up the negative 2, drops off, leaving the x minus 2. 3 to the negative 2 is what? 1/9 equals x minus 2, and then add the 2. And I get x equals 2 and 1/9, which you can leave. On a calculator, you probably won't see that though, right? On a calculator, you'll see this as a decimal. So you can also figure that out when you get your calculator. You can also write this as 19 over 9, the improper answer. All that stuff's fine, okay? Now we're going to go to the calculator. Yeah. Yeah. If you had this would be, if you had a calculator, it would probably want the answer in decimal form. If you don't have the calculator, then you would keep it exact like that. All right, so now we're going to go to the graphing calculator. Now it doesn't matter when I type it in, if I do it after I move the 6 or before, but you might as well just leave it as it is the first time. So 1y equals is going to be this whole left side, and 1y equals is going to be the right side. So I'm going to type in y equals, remember your change of base. Oh, if it's in there from yesterday, it's still log base 3. The change of base is on your math menu, and it should be x minus 2, close those parentheses, plus 6. And then the next one is just 4. Log base 3, x minus 2 plus 6. There's an extra parentheses on the end, but it does, oh wait, yes it does matter. So I don't want the plus 6 in these parentheses. Oh, I'm glad that happened. These should not happen. I need a parentheses around the x minus 2, but not after the 6. Go away. Oh my gosh. So they have to be separate. because the log minus 2 is what you're finding the log of. The plus 6 comes after it. And then the 4 obviously on the bottom. Now I'm going to graph. So the zoom I have now, it's getting cut off because of that asymptote, right? If I trace it, so if I go second, calc, and I go to 5, it wants me on the first curve, so I'm going to arrow over until my y appears. There I'm on the first curve. I'm going to hit enter. Then second curve, then hit enter, and then hit guess. And there's my intersection. So the x value was 19 over 9, or 2 1/9, which is that 2.111.
So why would you need the other word then if you could just do it?
Well, you probably won't have to do both. This is just to check it.
Oh.
Yeah. So most likely, I mean, especially on a test, if it just says to solve and you can solve it without the calculator, you would not have the calculator on this section. This is just like, can you check your answer? Could you do this on if you had this on your AP exam and you had the calculator, you don't have to do any of that other work. Yeah.
It's not working on my.
Did you shift over? All right, so what did we say the ln is? Log base e of the square root of x minus 5 equals 3. There's only one log, so we convert this to exponential. The e picks up the 3, leaves the square root of x minus 5. All right, so how do I get rid of the squared? Or how do I get rid of the square root? Square both sides. When I raise e to the third to the second, what happens there? E to the 6th equals x minus 5, and then I would add the 5. Whoa. Add the 5. And x equals e to the 6th plus 5. So without a calculator, that's what my answer would stay as. Okay? And you might even say that as like a multiple choice question. It would say like which of these are, and that would be your answer. With your calculator, you're going to do e to the 6th plus 5, which is 408.429. E is above your ln. So when I go to graph this, I'm going to do ln square root x minus 5. Make sure you come out of the parentheses. And then on the next one, I just do 3. And when I graph it, first of all, my x is 408. So do you think I'm going to see it on the graph? No, I have to adjust that window. So that means you could either zoom out a lot if you know what your answer is already. Like if I know it's going to happen that the x is not until 408. Wait for it. Then I can zoom all the way to the right, or I could keep hitting zoom out. If I adjust the x, so I need my x to go, window, I could literally make my x min 400 and my x max like 410. It's gonna look weird. But I might be able to find the intersection. I actually don't know if I can. That zoomed in, but let's see.
Do these.
Look, it did it. So even though it looks like it's not overlapping, I mean, even though it looks like it is overlapping, it still caught it. Huh?
You can see it better.
Okay. Yeah.
Can you show how to plug it into the calculator?
Yes. Looks like that.
But how did you put the ln?
The button is like right here. The ln button is under the log button. I mean, if you did change a base, you can make it log base e, but that's harder. Yeah. And then what was your window? What was that window? Daniela, what was your window?
X min -10, x minus 500, y min -10, y minus 500.
Okay, you can see the curve a little bit better.
Wow.
So there are going to be times, let's say we didn't go through the solving first and you had to graph it, realize it could be really hard to find because it might be all the way to the right. If you, or all the way down, wherever it is. You could also zoom in and out. So don't freak out. Like if it's big, it's going to be harder to find.
Wait, how do you find out when it's like on the?
How does graphing, so with the x value of your intersection is x,
Oh, okay.
right? Like look. That's your x. Yep.
And then like, would it ask you to make us draw it or no? We just
No.
confirm with our calculator.
So what's funny is some of the questions, and you'll see them when we get to the practice on it, but some of the questions say like, if you don't solve using algebraic, and you use the calculator, you have to describe step by step how you use your calculator. So you actually have to tell them how you got to the answer
Wait, for what?
on the AP exam.
Like write
Wait,
it out?
like
Correct.
all of the calculator?
No.
Oh.
Wait.
Like for an open, let's say for the free response, not for multiple choice, but for the free response questions, it will say something like solve algebraically. Like if you did not solve algebraically, which means you would show your work like we did there in the work, right? That's fine. You do the work, that's your answer. If you use the calculator to find this answer, describe how you use the calculator to find that answer. And you would literally have to write my y1 is this, my y2 is this, I graphed it, and then I use the intersection to find the x value. You would literally have to describe your strokes. Or you do the algebraic part. But there are times in which it literally says, like, you're justifying your steps. How did you do that? Because obviously they can't see how you did on your calculator.
Why for the second slide is the y the answer?
So, all right, so now
What is like when it gets in the wall?
you do. All right, so now look at example, what are we on? Example 5. What do you notice changed? There's an inequality. So when I'm solving, I'm obviously just going to follow the inequality rules. And these answers will be in interval notation. And then when I look at a graph, how do I know what I'm looking at? Because it's no longer the intersection, right? The intersection's important. But if I have let's say you have a line, and then I have a log function, this is where I would say the TIs that are colored are helpful, because you can look at them that way. But if it is, when is this greater than this? Let's say it said, when is the log greater than a number? Now I'm looking for when the log graph is above the horizontal line. If it said log less than the number, now I'm looking for where the log is below the line. So you got to pay attention to things like that.
So greater means like
Greater, so it depends on what's greater. So like if the left, you want the left greater than the right, then you want the graph of the left one to be above the graph of the right one.
In like y terms, like greater.
Correct.
Y.
You're giving the x values, but you're looking for where the y values are bigger or small. Yeah. And also you have to pay attention to your domain restrictions here. So what are domain restrictions on logs? What's next to the log? Well, the asymptote causes a restriction on the domain, right? But how would I know what that restriction is?
Horizontal.
It's the horizontal shift, which comes from the parentheses, right? Whatever's there has to be bigger than 0. It can't equal 0. It has to be bigger than 0. So before I even start A, I can look for those domain restrictions. None of these can be less than 0. So this has to be greater than 8. This 3x minus 4 has to be greater than 0. So 3x has to be greater than 4. And x has to be greater than 4/3. Now it has to be true for both of these. So you have to pick the narrower one. If you need to see it on a number line, graph it on a number line. The first one is 8 and to the right. The second one is 4/3 and to the right. So what's my domain? Greater than 8. So my domain, x has to be greater than 8 or 8 to infinity.
This is, what you're showing is what's allowed, right? Not what's.
That's not my answer, but that's the lowest my answer can be.
Oh, okay.
Yep. So I have to remember that at the end. At the end, if I get a this has to be less than a number, it can be less than a number, but it also has to be greater than 8.
Okay.
What if they like point in opposite directions?
And they don't overlap, it would be no solution. So we'll talk, when we get to the end, I'll graph it with it.
Like if the domain restrictions.
If they don't overlap, then no solution. Yeah. All right, so now I'm going to solve it as though it was, almost as though it's an equation. There's 2 logs on one side, so I'm going to condense those. I get log of x minus 8 times 5 is less than or equal to log of 3x minus 4. I ignore the logs. 5x minus 40 is less than or equal to 3x minus 4. Subtract the 3x. 2x minus 40 is less than or equal to negative 4. That's a minus. The 40. 2x is less than or equal to 36. Divide by 2. And x is less than or equal to 18. So it has to be less than 18, but it has to be greater than 8. Less than or equal to 18, but greater than 8. So what does this look like in an interval notation? Yes. Nope, it's got to be greater than 8, right? So parentheses, 8, 18, bracket on the 18. All right, go to B.
Can you scroll up a little?
Now there's only one log, but I got to isolate it. So I'm going to add the 3. Well, first of all, let's do the domain restriction. Just from that one parentheses, I would know x has to be greater than negative 5. Right? Can't be equal to because then it'd be 0. So log base 3 of x plus 5 is less than 1. And now there's only one log, so we convert to exponential. 3 to the 1 goes on the left. Order's important here. No, sorry. 3 to the 1 goes on the right because the sign stays the same for the rest of it. So it looks like this. X plus 5 is less than 3 to the 1. So the 3 went on the side with the 1. Obviously now order's important. So then I'd get x plus 5 is less than 3 and x is less than negative 2. Set this equal to 0 or greater than 0. That would find you, because the actual asymptote would be at negative 5, not positive 5. Remember, it's the opposite sign. Yeah. All right, so now think about our restrictions. Initially, we said it had to be greater than negative 5, so it would have been in parentheses pointing to the right. Now we're saying it has to be less than negative 2. It would be a parentheses pointing to the left. So where is my answer going to lie? Negative 5 to negative 2 with a parentheses on both. Kylie.
Why isn't there a bracket on negative 2?
Because this, because it can't equal. So the interval, the domain is always greater than, because you can't find the log of 0. So it's not greater than or equal to 0, it's greater than 0. So the ones we get from our parentheses, you set it greater than 0. That will never have a bracket. And then the other one is determined by the sign, the inequality sign in our equation. The first one had a bracket because it was or equal to. The second one does not because it's less than. All right, so I'm graphing B. So log base 3x plus 5 minus 3 is my first one, and then negative 2 is the second one. Now I'm going to hit graph. Oh, my graph's going to be really weird because of because it's from before. So if I zoom in on it. Wait, did I hit zoom in or zoom out? Hang on. All right, so now if you look, okay, my goal was where it's less than it. So I'm looking for where the red, I'm looking for the log, which is the blue, is underneath the red. It starts at negative 5 because that's where my domain starts, and then it stopped at negative 2, and then the blue went above the red. So it's consistent with what we just did. All right, example 6 says solve, then check using a graphing calculator. Make sure you include the domain restrictions. Is there a domain restriction on exponential? No, so I don't have to worry about it this time. It's going to say those instructions because you have to pay attention to it. But there's actually no domain restriction when it's an exponential. So for this one, I'm going to add the 2. 4 to the x plus 2 has to be greater than 64. Can I change 64 to have a base of 4? Yes, it would be 4 to the third. And now I ignore the bases. Look at my exponents. X plus 2 has to be greater than 3. And x has to be greater than 1. And that's it. It'd be 1 to positive infinity. There is no lower bound on exponential. So now when I graph this, I would graph this as one y equals, this as the other y equals, and I'd be looking for where this one is above this one. And that's how you would know to confirm your answer. So let's graph at least one.